Yeah, so I'm Mikhail Panchenko, or Mike, or Pancakes is what everybody really calls me. I am the general manager for site engineering at New Relic, which really just means that I'm responsible for the technical strategy and roadmap for our internal platforms. And so, real quick, what is New Relic? New Relic is an observability platform. And what is that? What even is observability? I'm just kidding, I only have 10 minutes. But what we think of as an observability platform is a platform that absorbs the data that is emitted by your apps and your infrastructure, whether it be metrics, events, logs, or trace it. You emit it, we'll consume it, and we'll help you make sense of it. That is our goal. And the platform that we run is open, connected, and programmable. And I'm going to show you, I'm going to illustrate that with basically a case study of how we ourselves monitor New Relic with New Relic. So New Relic, aside from being an observability platform, is also a complex infrastructure. We have over 500 services. I think that number is trending down-ish, but until recently, the joke, which wasn't a joke at all because it was the truth, was that we had more services than engineers. We think the humans have started to pull ahead recently, so that's a good trend. But the point is there's a lot of stuff to manage. We also have NRDB, which is the New Relic database. It's a proprietary analytics database that we built in-house, which is, for the intents and purposes of this talk, is a complex distributed system. There's several tiers to it. There's a lot of state. There's a lot of coordination going on. So it is quite a complicated thing to monitor. We have a Mesos Marathon-based platform that we use for deploying most of our stateless services like HTTP services and Q consumers that we deployed around 2016, right before the choice became more obvious. However, it's worked really well for us. What we found, though, is that we've been unable to serve our internal customers that run some of these more complex stateful services. Trying to get that working on Mesos is just too complicated, too brittle. And so as a result, we're moving to Kubernetes with an emphasis on those systems first. We're doing all this, by the way, while we're processing 1.3 billion events per minute, which is about 23 million per second. So we're keeping pretty busy. And, so what are some things in our infrastructure that emit data? One thing are obviously services and applications. Those things emit tons of data. Notably, they emit traces. And so we, being the good eaters of our own dog food, or if you prefer the more positive framing of drinkers of our own champagne, we pump all of those traces into our distributed tracing product. And what's cool about distributed tracing, which obviously we're not the only people that do this, but you're able to see your request all the way through an infrastructure. Where it gets more interesting from the platform perspective is that if you're also sending the logs for your services to our platform, which we do, first things first, we do support some of the more common tracing frameworks, and we are participating in the OpenTelemetry standard development. So that's where the openness comes in. We're trying to get data from anywhere we can get it into this tracing system. The other thing is we send our logs to our logs product, and because we have instrumented our services with basically, for the entirety of the platform, and we've linked everything up, we can actually see logs for a particular trace in the logs product. So you just click that button, you go to logs product, which, here's just a screenshot of the logs product. It's like many other logs products. You send your logs there, then you're able to search and filter. What's a little bit more unique about our product, though, is that it builds on the technology we already had, where you're able to assign attributes to every log line. And so that's what enables that linkage with distributed tracing. But it's not just that, right? If you look at the left-hand side, there's all kinds of attributes that you can filter your logs by that are already pulled out for you. And that's really powerful, right? You're able to, we'll get into what that looks like in a little bit. We also, aside from applications and services, have the platform on which those things run. And more in the present and the near future, that's becoming Kubernetes. And one of the things we're doing is we're running many Kubernetes clusters. We're rolling out a cellularization strategy in the process where we're breaking up some of our large internal clusters into smaller clusters, and we're basically, Kubernetes a Kubernetes cluster is becoming our unit of scale. Now, a Kubernetes cluster on its own is complicated enough, but fortunately we've built this tool called the Kubernetes Explorer that allows you to pull all the data from your Kubernetes control plane into the product and then visualize it in a helpful way. This lets you see down to the container level how your pods are doing in the cluster, right? So here we've clicked through and opened a specific container in a pod, and we can tell how much CPU it's using, how it's doing relative to its memory allocation, and then we can also see that all the hosts are healthy, right, in this particular instance. But again, because we've instrumented for the whole platform, we're able to then say, okay, let me see the logs for that specific container right there in the Cluster Explorer. That's really powerful. But that's not it, right? If you go back to that screen from distributed tracing, when you look on an individual trace that happened in a particular service, not only can you see, through like the service level trace on that same screen, but over here on the right, you can also see which Kubernetes node it hit and which pod it was part of. So you're able to reason about whether or not a particular node in your Kubernetes cluster is having issues and is causing these problems, right? And you have that all right there. If that's not enough for you, if that's not enough power, and you want to ask a more precise question, we have our dashboarding capability and our query language, NRQL, or as we call it, NRQL. What NRQL lets you do is query the individual samples produced by all of our different integrations, including the Kubernetes ones, and ask it whatever questions you want. So for example, here I've written a query. I'll just read it out since it's kind of small. From Kubernetes node sample, select unique count, node name, facet cluster name, and then limit, time series, et cetera. That's less interesting. But what we're doing is we're counting the unique nodes per cluster. And so this is basically the adoption curve of Kubernetes at New Relic. And that's just one of the questions that you're able to ask. If you just go into the NRQL query bar and you say, from, let's say, container sample, which are data about containers in a Kubernetes cluster, select and just hit space, you will see all the different things that you can query. You can count these things, you can count unique instances of a particular thing, you can facet by them. Those are all the different attributes that we pull in. It's super powerful. If that's not enough even, you can now also build your own custom NR1 applications. NR1 is our new platform that allows you to build whatever functionality you need that is specific to your needs into New Relic, and also share that with other organizations or other teams within your organization. So for example, here's an example of a thing that we will probably make available when we've polished it a little bit more. The team that's responsible for running all these dozens of Kubernetes clusters has built an application that allows us to see when versions of a particular image diverge across the fleet, right? So here we see that we have 42 total clusters and 2 images have diverged in version, and it even tells us the exact clusters that have sort of drifted from the mainstream. It's super powerful, allows us to run these dozens of clusters more like one big cluster and reason about what's happening and where things have gotten inconsistent. You know what else emits data? Teams of humans. Bet you didn't think that, but they do. And I don't mean data like how many lines of Git you've submitted. That's really hard and unhelpful to measure. But what we do know is that there's certain things that slow our teams down. Interruptions. Right, so at New Relic, most internal teams have a hero channel where people go to ask for help. Every time someone asks for help, that's a distraction from your other day-to-day work. Anytime you get paged, that's a distraction. And so we've built a custom NR1 application that literally tracks the metrics about our teams that we know slow them down, and also tracks how they're doing against their reliability commitments. And so now, our management and leadership is able to look at that and see when teams start to get in trouble, see when teams start to have, pager load that's too high, right? We see a spike up to 14 off-hours pages on a particular day. That's bad, right? We know that that's going to slow our organization down, and so when we see changes in those trends, we know that we need to invest and make things better there. So if it emits data, you can put it in the New Relic observability platform, even if it's humans. Now, I only had 10 minutes, so there's a lot more to talk about. We will be at the expo, we'll be at booth P12. A bunch of our product managers and engineers are here. If you have any further questions, or you're just interested in the platform, or you just want to chat, pick up a t-shirt, make some new friends, please come by our booth, we'll be there. Also, if you want to ask me any follow-ups, or if you want to just, again, meet another person, here's my contact information. I used to put my Twitter up there. I don't tweet anymore, so LinkedIn's probably better. Anyway, that's it. Thank you.